Hello and welcome to MSR Live's first episode of 2021. Hope everyone is well. Today, Chris Reddington will be with us and we'll be talking about cloud design patterns. Hi Chris, how are you? Welcome.
Good, thank you. Thank you for having me on the show. Glad to be here, Mert.
Thank you very much. And before we start, this is my classic question. Can you please introduce yourself?
Sure, yes. So, Chris Reddington. I'm a fast track for Azure engineer at Microsoft. So, work at Microsoft, have been there for, I think, 6 or 7 years now, and work with customers every day on Azure technologies. So that's what we'll be talking about cloud design patterns today, some of the things that maybe I've seen along the way, and just sharing some tips and tricks for all of your listeners.
Okay, thank you. So you said that fast track for Azure. What is fast track for Azure?
Yeah, good question. So when you think about a organization going to Azure, it's quite complicated, right? There's lots of different technologies to choose from, lots of ways you could go and do it. So Fast Track for Azure is a team inside of Microsoft. We are part of Azure Engineering, and we're there to help guide customers along the journey. So there'll be partners involved, there'll be the customer themselves, but we're really Azure Engineering coming along and helping the customer get onto the platform. So we care about two main things. Are customers enjoying Azure? Are they having a good experience? And number two, how can we improve the platform? What are the things that we can learn from those projects along the way, and taking that feedback straight back to the engineering team? So lots of learning and lots of fun as we help organizations go and build on the cloud and build on Azure.
Okay, great. So I'm a big fan of your Cloud with Chris
Thank you.
blog and vlog series. So I wonder how and when did you decide to start Cloud with Chris?
Yeah, sure. So I was thinking about this earlier, actually. It's coming up to a year since I started thinking of Cloud with Chris. So I think it was March last year that I started. And back then it was just a podcast. That was the first thing I was starting with. And eventually then I decided I might move towards streaming, blogging, etc. I'd done blogging in the past. But like a lot of people, trying to keep up with it is always the challenge and keep that momentum going, which is why I started with podcast. I find it easy to talk, more difficult to kind of write and put things down. And then that just transformed into streaming and video recording. And that, I guess, the streaming and the video recording side really started around August or September. And then going into 2021, I wanted to be very, very focused on the community work that I'm doing. So giving back to the community, doing more content, giving more content. So I'm trying to do a vlog a week, a blog a week, and then some kind of technical video as well a week. So we'll see how that goes. Still early days, but at least I'm keeping up at the moment. So yeah, cloudwithchris.com if anyone's interested. It's a good fun just to record and share some content with everyone.
Okay, great. So we have a very long title today, but I want to ask this question in short. What's a cloud design pattern?
Sure. Yes, it's a big topic, so we'll see how we can condense it for the viewers here. So cloud design pattern, if we take cloud out of the title for a moment, a design pattern is really just something which has been proven. It's a practice that people use over and over again. So if you think into the software development space, there may be things like, the factory pattern, the singleton pattern, for example, that people are very familiar with. And these are just ways that people design and kind of use things when they're designing software. And when we think about cloud design patterns, it's exactly the same. What are some of those patterns that have been used in the past that might be available for people to go and use over and over again, that are proven patterns? And the interesting thing is, even though we call it a cloud design pattern, some of them aren't really cloud design patterns. Some of them are things that have been around for a long time, which we'll see in a moment when we take a look through the Azure Architecture Center. But there are some new ones that, because Azure, the cloud is kind of growing and evolving, there are some new ways that we can approach how we design our solutions, design our applications, and those are all really well documented. So we'll take a look through some of those. So I'm just going to show docs.microsoft.com. And if you've never navigated through docs.microsoft.com, you may not realize that there's actually tons of different documentation pages you can go and look at. And there's one in particular that I want to show here, which is the Azure Architecture Center. And the Azure Architecture Center is, I think, just a really, really great tool because it has documentation around things like cloud design patterns that we'll talk about today, but also things like anti-patterns. So some of those things maybe you shouldn't do. Also things like good principles to go and follow when you're designing your projects, thinking about availability, resilience, scalability, and all of these kinds of topics. So if I just click on application design patterns here, you will see on the left-hand side that there is just a whole list of different design patterns here. There are so many that you can go and look at. So by no means do you have to use all of them at all. And we'll talk about that a bit as we go through here. Use the right pattern at the right time, and maybe we'll explore when you should use those as well. But there are so many documented, and I know there are people on my team, for example, that are working to actually document more that we are seeing come up as well. So hopefully that gives a bit of a clue to what cloud design patterns are for your listeners here.
Okay, how many patterns are there? I think the answer is too many.
Yeah, probably. I think so. There's probably a design pattern for anything. And I think that's the thing is, just because these are proven practices doesn't mean you have to always use every single pattern, right? You have to figure out what is the right pattern for my scenario. And I think that's part of the challenge is, when do you know when to use these patterns? When is it right to go and do that? So the way that I always start the discussion, and if anyone's listened to any of my podcasts or videos and is listening, they'll know that I always bring it back to requirements. Really, really important to always think about requirements, because the danger with design patterns is that you could go ahead, use all of the design patterns, but you've got a really complex system that no one can understand. It works well in theory, but actually in the real world, maybe it costs a lot of money, or it doesn't meet some design requirements that you have. So you always need to bring it back to those requirements. But I think there's something like 30 or 40 different patterns just here. And this isn't even looking at, software patterns like retry and some of these other things that we might be commonly thinking of in the cloud as well. So a lot of them there for sure.
Okay, I am working as a software architect, so there are three main groups of software design patterns. So, creational, structural, and behavioral. Yeah. Are there any groups in cloud design patterns?
Good question. I guess actually it's probably, if I scroll down a little bit here, I think it's probably to do with the non-functional requirements or the type of area that you're really looking at here. So if we think about a few different features of a solution in the cloud, we might care about the availability, we might care about scalability, we might care about monitoring that application, for example. I think rather than being certain approaches, you're probably going to be thinking about them with certain non-functional requirements in mind. And that's typically how at least the Azure Architecture Center has gone ahead and split these out into different patterns. And it's important to say as well that just because there's a pattern in one section doesn't mean that it can't be in another section as well, for example. So there are some, for example, that might focus on availability. They also might focus on resilience and performance and scalability. So they could potentially address a few concerns that you have in your solution as well. So that's really how you kind of think about them from a cloud perspective there.
Okay. Are these patterns vendor specific?
Good question. I wouldn't say so. So maybe let's go ahead and jump into a particular example, maybe a lightweight one here. So let's look at circuit breaker. So I won't go really deep in this for now. This is probably not the right time. But the idea behind circuit breaker is if you think about the scenario where you have your application and your application is going ahead and calling another service. Maybe it's an API, maybe it's a microservice or some third-party service, for example. And that third-party service or that microservice that you're calling goes down for some reason. What do you do in that scenario? Because you don't want that to impact the rest of your application, right? You want to make sure that your application can at least continue in some way. So the idea behind the circuit breaker pattern, if you think about like electricity and that literal circuit breaker that you have on your circuit board, if there's an overload in the system, it switches the switch, it makes sure that the electricity can't pass through, and it protects the system. So it's the same idea with the circuit breaker pattern here. How can you go ahead, recognize that the system is about to get overloaded or something is going wrong, flip that switch, prevent that system from getting overloaded, and then check periodically, are we able to now go ahead and reactivate the system? Is everything healthy and safe for us to start over again? So if you think about a pattern like that, it doesn't really, lend itself, let's say, to one vendor like AWS or Google Cloud or Azure in particular. I think it's something you could use across any of them or all of them. The application, when you actually get to the nuts and bolts of it, will probably be slightly different, but really these are all theoretical patterns there. So I wouldn't say they're vendor specific really. Probably can be used across all of them, I think.
Okay, thank you. So are there any patterns that you can say you must know this?
Oh, wow, good question. So I think this is one of them. The circuit breaker pattern preventing your service from being overloaded and those other kind of downstream or upstream services impacting your solution is important. I think as well, if we take a look at something like the retry pattern. So the retry pattern, I consider it just a foundation of working in the cloud. So let's just think about, maybe an on-premises environment for a moment and think about a world where we're just working in a single data center. We probably don't have to worry about things like reliability issues because we're in the same data center. So the network links that we have are very good. They're all over Ethernet cables inside the data center. If there is an outage, it's probably going to be our entire rack or our entire data center. So we have a bigger problem. But if you think about the scenario of the cloud, you have to deal with things like the internet. There are scenarios where, a link might be there one moment, you call the endpoint again, and that link disappears for some reason. We call that a transient fault. And then you call it again, and then it's back again. So there may be times like that I, as a client, I call my API, but it's not there. So what do? If I don't try and retry that pattern, then I just go back to the client and I say, sorry, that thing doesn't exist. And as an end user, I don't know how the application is built. So I think it's my fault. I think something's wrong. And I have a bad experience with the application. And that's where something like the retry pattern is really important because we don't want our end users to be impacted by something which, maybe our database is overloaded for one moment and it says, sorry, I can't take any more requests. So we try again, and actually the next time it's absolutely fine. We don't want to put that problem to our end user, so that's where we use something like the retry pattern. So again, that's another one where I would say a very important pattern to be aware of because there are just so many ways where there could be faults in the cloud, and it's one of those things that you just design for those faults because you're working over the internet. It's probably going to happen at some point, so you work with some of these design patterns and build them in from the very beginning. So I'd say those two are probably some good ones. I think as you move along your journey into the cloud, there are things like the queue-based load leveling pattern. So using queues to decouple different services, for example, which are very important. Maybe something like competing consumers. So if you have a queue, being able to take loads of messages from that queue and process something at load and scale those backends is, again, a good pattern there as well. And, we could keep expanding and going, but I think those are probably some of the first few that I would probably look at along my cloud journey there.
Okay, thank you for the information.
Sure.
So implementing a pattern not an easy thing. So what kind of problems may I face if I don't implement any pattern?
Yeah, so I think the risk of you not implementing the patterns, maybe let's take a scenario. Let's think about taking an application that we have running in our data center on premises today, and we just want to go ahead, take it from on premises and lift and shift it straight into the cloud. And that can work. It depends on the application, but we need to be careful. So if we think about that, that example of the retry pattern that we gave a moment ago, when we move into the cloud, if we have our application server over here and our SQL database over here, and they need to speak to each other over the internet, if for some reason that application server is not able to connect to the database, the application server probably hasn't built in the resilience or the capability of dealing with that problem, because that's just not something you have to deal with on premises. So you're going to start probably getting some strange behaviors in the cloud. So there may be times, if you want a really good experience in the cloud, that you might need to re-architect or slightly adapt and rewrite some code. I'm not saying a full rewrite of the system, but just bringing some of those patterns in just to make sure that you're building it for the cloud, you're building it cloud native and building it so that it'll make sure it runs well in that environment. And if we think about maybe not a design pattern, but more of a principle, I guess, might be a better way of thinking about it. Let's think about state as well for a moment. So if we think about, a shopping application, a retail scenario, for example. So we've got a website. Our users go into the website. They've got a shopping cart. And I, as a user, I log into contoso.com, enter my details, put my various groceries in the shopping cart, and I'm ready to check out. But in the back end of the web application, something has gone wrong and the server has died. In a world on premises, the server probably isn't as likely to die because you control it, you're looking after it. It's like a pet. It's something you look after, as opposed to cloud, which is more like cattle, where you just want to make sure that the thing is running. You don't care about that machine so much, you just care the application is running. The difference between the two there with states is really important to understand, because in a cloud scenario, one of the reasons we've probably gone to the cloud is we want to scale that application up. We might need to scale it up very quickly. Likewise, when the application isn't being used, we want to scale it down because we want to make sure we're optimizing for cost, we're not wasting any money. So think about that scenario where you scale out your instances, but then scale them back in. So if I'm that user that's added my groceries to the shopping cart, and the state is stored on that particular instance that is about to get scaled in and removed, then when I go ahead and click the submit order button, if the state is staying on that machine, then my experience might be a bit strange, because I'm about to go to the checkout and now suddenly all my groceries have disappeared. I've spent 20 minutes, 30 minutes shopping and choosing what bread I want to buy, etc. And now I've got to go and do that all again. For me as an end user, that's a terrible experience, and I don't want that. So thinking about that end-to-end scenario and thinking about things like state and how we deal with state are important to understand from a cloud perspective, and how they deal with scaling out, scaling in, and all these other kind of cloud concepts. So I wouldn't say just cloud design patterns, but thinking about those cloud principles, I think, is really important as well.
Okay, thank you. So you mentioned about the lift and shift scenario, but I wonder about the other ones, for example, cloud optimize and so on. So I want to ask, what about software design? I mean, should I change my software architecture for cloud?
Yeah, good question. Yeah, it's a really interesting question. I don't think you always have to change the architecture. I think it really depends on what you want to achieve. So if we think about lift and shift as a scenario, you can absolutely go ahead, take an application, lift it, and redeploy it into the cloud, or even just migrate it, using various tools, for example, and just literally drop it into the cloud. I think the important thing to understand there, though, is the experience that you'll have in the cloud is going to be different depending upon how much you're willing to invest in changing it to be designed for the cloud, if that makes sense. So thinking about that scenario a bit earlier, the scaling out and in scenario, if it's accepted that your users might have a bit of a strange experience when they go to the checkout because of scaling out and in, then sure, the application would run just fine. But there's obviously an impact to your end users. And I think really the importance is connecting it actually to one of my other favorite topics, which is DevOps. And when we think about applications that we build these days, our users are the most important thing that we need to think about, right? Because why do we build applications? We don't build them just because we like building, right? There's a purpose that it's serving. And who is the person that gets really annoyed or frustrated when something goes wrong? It's our end users. And we need to make sure that we're putting them front and center. So if we don't do that, then why are we building our applications? So I think that's really where I would start thinking about why we should start changing the software architecture. What is the benefit of changing that architecture? Not just from a technology perspective, but actually to the end users and to the experience that we're providing them. That's really the important thing. So the software design might change. I think it depends how much effort that we can really put in, because we also need to be realistic. Architecture is sometimes theoretical. We need to make sure that actually it's based in real world as well. So do we have the development capacity to be able to deal with that? Do the teams have the knowledge to be able to deal with that? Because we want to make sure that actually the team have the right knowledge to go and do a good job as well. We don't want to make changes before they know what they're doing there as well. So I think there's a few factors to it, but ultimately there's a different scale. You can migrate, you can modernize, you can re-architect, and really it's ultimately how far do you want to take it along that journey. And you don't have to do it all at once. I've seen a lot of customers where the first thing they'll do is lift and shift. And as soon as they get into the cloud, they go, cool, we're there now. How do we now change this thing to be more like that thing over there and be modern and cloud native and, able to scale out and do all of these really great things in the cloud? Because, they want to scale out, they want to be resilient. And there are some applications which are legacy based, which can't really be architected in that way, and they need to re-architect. So depends on the application, depends on the scenario.
Okay, thank you. So let's have a role play. And for example,
Sure.
I'm your customer.
Okay.
And I don't trust a single vendor, so I want to use multiple vendors at the same time.
Sure.
And is there any multi-cloud scenarios or patterns?
Yeah.
And this is the first one. And the second one, I have a local data center.
Sure.
And I want to use cloud, but not for all my resources. I want to use a hybrid cloud. And are there any patterns for this scenario?
Yeah, good question. So obviously it will slightly depend on the application that you're talking about and how you're going to use those multi-clouds. But I think, again, some of those patterns that we talked earlier about, things like circuit breaker, things like retry, etc., they could all be used in a scenario for multi-cloud. Let's assume that the reason as a customer that you're going ahead and using multi-cloud is maybe not because of trust, but because of resilience. And you want to go ahead and make sure that if there was a problem with one cloud for whatever reason, that you can still carry on running across other clouds. Well, to do that, there would be some really complex requirements around data synchronization and data replication, which definitely we won't get into now. That could be a session on its own. But we could think about things like using circuit breaker, understanding that if you're trying to communicate to one cloud and there's a problem, then you prevent it going to that cloud, you turn that tap off, retry it, and send it to another cloud instead. I should have used some pointing to point at the different clouds behind me as I'm talking. But yes, you could do something like using those patterns. And there are technologies out there that can help you with that. I mean, the challenge that you get really with something like multi-cloud or hybrid cloud, maybe less hybrid cloud, we'll come back to that in a moment, but multi-cloud is you're going to be working to different standards potentially. So you've got something like Azure App Service would be different to Google App Engine, would be different to, let's say, the different options that you have in AWS, for example. So you then start having to have expertise in each of those different clouds potentially, unless you use something where you can go ahead and deploy consistently across those environments. So using something like virtual machine images, or using something like, I don't know, Terraform and Ansible to go ahead and script those things out. Yes, there are still differences, but it gets you closer. Or using something like Kubernetes and being able to deploy consistently across those environments because the underlying platform that you're hosting on is exactly the same. And that's where something like hybrid cloud is kind of interesting, because if you think about the Microsoft space particularly here, and think about Azure Stack, the way they've designed the management plane for Azure Stack is it also uses the same kind of APIs that Azure Resource Manager uses. So whether you're deploying to Azure Public Cloud, or even an Azure Sovereign Cloud, or Azure Stack, then you could go ahead and still use the same ARM templates, the same APIs, and go and deploy once across all of those environments. So as you start moving across different clouds, the amount that you can use the same stuff and the same investment, the same code, maybe not the code, I guess the code would stay the same most likely, but the same deployment approaches, the same underlying architecture and infrastructure is going to vary. It really depends on what underlying technologies you use. And if you use something like Kubernetes, then you can start standardizing a little bit more because you've got Kubernetes as your underlying platform. But then how you set up the underlying Kubernetes clusters will be different on each platform. So there are elements that you need to understand the strengths, the weaknesses, the nuances of each of those different cloud platforms and how to design for them. But ultimately, choose your technologies wisely, because I think with a multi-cloud scenario, there's definitely benefits to it, but there's also the overhead of having to manage different platforms, not just from the technology side, but the billing, the cost, the resource access, the governance, all of those things which maybe aren't the most interesting and exciting sometimes when we manage cloud deployments and cloud applications. You then have to go and think about those things as well. So it's not just about the technology side, it's about everything else that then comes along with that as well.
Okay, thank you. And you show some cool documentation. It has an official Microsoft documentation for cloud design patterns.
Yes.
Is there any learning path for this documentation? Because there are lots of design patterns. And in short, I want to ask, and where should I start?
Yeah, good question. So I think taking a look through the Azure Architecture Center is a good place to start. So being able to go ahead and just come in here, and based upon your scenario, you could go ahead and say, right, I want to start learning cloud design patterns, or I want to know what the principles are of a well-designed application. I want to go ahead, for example, and browse different architectures that are already out there and have been designed for different scenarios. So based upon your scenario where you're entering, you might be an expert in certain areas of the cloud already. You might be starting brand new. There'll be something in here for you, and it's very well laid out in terms of the different technology areas. There's also another area which might be useful, which is the Microsoft Learn platform. So if you haven't used Microsoft Learn already, definitely go and use it. It's a very, very good platform. And what you can do with Microsoft Learn is you can go ahead and look through these different learning paths, these different modules, for example. And for example, there's this one module in the bottom left here about the Microsoft Well Architected Framework. If you haven't heard of the Well Architected Framework before, definitely go and take a look at that. That's something I really recommend. It's a bit like a set of pillars and a guided way of being able to look at a cloud application and cloud architecture and be able to look at some of the areas which might be opportunity areas, for example, for you to go and focus on. And this is just one example module, right? Because if we go and navigate back to the browse section, I can go ahead in here and start looking at the different types of roles, for example. So whether I'm a DevOps engineer, a student, maybe I'm a solutions architect for the purposes of this, you can see all of these different modules that are available here. And you can even filter down based on the learning paths. So start looking at, for example, what are the core Azure concepts, the core Azure services, all the way through to looking at architecting network infrastructure, managing your resources, infrastructure operations. You get the point. There's so many different areas that you could go and focus on and take a look at. So I think depending on your background and what is interesting to you and where you want to go forward and take that, you could use Microsoft Learn and go ahead and use some of these modules there. And it's completely free as well. You can go ahead, log in, get going. Some of them are a bit more, let's say, theoretical. You have to read things, some videos, for example. Some of them have knowledge scenarios where you have to actually go log into the Azure Cloud Shell. They spin up an environment for you. And you have to actually go and make some things as well. So they are practical in some cases as well. So really good resource, Microsoft Learn. Definitely recommend that one.
Okay, thank you. This is another my classic questions of MS Live.
Sure.
What challenges may I face while implementing these patterns?
Yeah, sure. Really good question. So I think there are a couple of areas which are important just for people to bear in mind, because I know we focused the discussion on why you should use cloud design patterns, but I'm going to spin it around a little bit and say why you shouldn't use cloud design patterns as well. I think people can fall into the trap of designing for nirvana, designing for that end goal. But this is the real world. We have time deadlines, we have cost restrictions, budgets, etc. So we need to get a solution out there. So we could design the most theoretically amazing system, but never ever get it deployed. And I think that is the danger with going into analysis mode with requirements and cloud design patterns is look at the requirements, look at the things that you really need to achieve and the absolute most important and critical things that you need to focus on. And design for that first step and then iterate over that. Start using these DevOps concepts to be able to grow and evolve that architecture over time. Because you don't need to solve it all at once necessarily. You can grow it over time and start adjusting the architecture slightly. Obviously there are some things you need to decide up front. And I think that's going to be the important piece, is not letting that design pattern approach and using all of them lead up front. Make sure you ground yourself in the requirements. Make sure you focus on things like cost, because cost is absolutely a pillar that you need to focus on. And don't overcomplicate things. If you can design something, if I've got an application where I have a 95% SLA, I don't need to go multi-region. I don't need to go and use something like a whole load of resilient different patterns in that scenario if I'm okay with the application being down for a few days to go and recover it. So don't over-architect as well, because there is a cost of running that, not just from the monetary value of technology and the payments to your cloud provider, but also operations and keeping the lights on your operations team. So make sure that you're not overcomplicating things is the real risk, I would say. There, I think there is a risk of that when people start looking at cloud design patterns and going down that rabbit hole.
Okay, thank you. Chris, thank you very much for joining me today. This was a very informative session for me. I hope everyone like it. Hope to see you again in further episodes. And thank you again.
No, great. Thank you for having me. Very happy to be here and have had a lot of fun. Thank you.
Okay, my pleasure. See you. Cheers.